Utility functions are a particularly convenient way of representing preferences. In fact, by using utility functions, one can give a more condensed representation of games, as explained in the last paragraph of the following definition. Definition 2.1.3. An ordinal game in strategic form is a quintuple. Open straight bracket, capital I, comma, open parentheses, capital S sub 1 through capital S sub n, close parentheses, comma, capital O, comma, F, comma, open parentheses, better than or just as good as 1, ellipses, better than or just as good as n, close parentheses, close square bracket, straight bracket, where bullet point 1, the elements capital I and S capital S sub 1 through capital S sub n and capital O and F is a game frame in strategic form. Definition 2.1.1. Bullet point 2, for every player I, an element of capital I better than or equal to for player I is a complete and transitive ranking of the set of outcomes capital O. If we replace each ranking better than or equal to, better than, or just as good as for player I with the utility function capital U sub I that represents it, we assign to each strategy profile S. Player I's utility of f of S. Recall that f of S is the outcome associated with S. Then we obtain a function pi sub I, or pi for player I, colon capital S, the set of all real numbers called capital S yields the sum of all real numbers called player I's payoff function. Thus, pi sub I of S equals utility equals capital U of player I sub I of f of S. Superscript A notation. Note that in this book the symbol pi is not used to denote the irrational number used to compute the circumference and area of a circle, but rather as the Greek letter for P, which stands for payoff. Having done so, we obtain a triple. The elements capital I, the capital S sub 1 through capital S sub n, and the payoffs sub 1 to payoff for player n, called a reduced form ordinal game in strategic form. Reduced form because some information is lost, namely the specification of the possible outcomes. For example, take the game frame illustrated in figure 2.1. Let Sarah be player 1 and Stephen player 2 and name the possible outcomes as shown in table 2.1. Let us add the information that both players are selfish and greedy. That is, player 1's ranking is O3 is better than O1 for player 1, and O1 is better than O2 for player 1, which is just as good as O4 for player 1, and player 2's ranking is O2 is better than O1 for player 2, The following are for player 2, repeating player 2's ranking. O2 is better than O1, and O1 is better than O3, and O3 is better than O4. Is O3 is just as good as O4. And let us represent their rankings with the following utility functions. Note again that the choice of numbers 2, 3, and 4 for utilities is arbitrary. Any other 3 numbers would do. Outcome yields O1, O2, O3, O4. Utility function yields for player 1, capital U sub 1. And for the outcomes 3, 2, 4, 2. And the utility function for player 2, capital U sub 2. The respective outcomes are 3, 4, 2, 2. Then we obtain the reduced form game shown in figure 2.2, where in each cell, the first number is the payoff of player 1, and the second number is the payoff of player 2. We have the 2x2 grid box, the horizontal scores are for player 1, the rows for Sarah, and the columns, the vertical lines of information are for Stephen. So, and the quadrants are split still and split still. They'll vote to split. They both vote to split. In the first quadrant, they both have an outcome of 3. In the case where Stephen steals and Sarah splits, Sarah gets 2, Stephen gets 4. In the case where Sarah steals and Stephen splits, then Sarah gets 4 and Stephen gets 2. And in the case where they both steal, they both get 2. Figure 2.2, one possible game based on the game frame of figure 2.1. On the other hand, if we add to the game frame of figure 2.1 the information that player 1 is fair-minded and benevolent, that is, her ranking is O1 is better than O3, which is better than O2, which is better than O4, while player 2 is selfish and greedy and represents these rankings with the following utility functions. For the outcomes O1, O2, O3, O4, we have a utility function for player I, U of I, 4, 2, 3, 1. The utility function for player 2, capital U sub 2, is 3, 4, 2, 2. Then we obtain the reduced form game shown in figure 2.3. We have another 2x2 grid. Sarah again on the rows with split and still, and player 2, Stephen, is on the columns, split and still. So in the case where Sarah splits and Stephen splits, then Sarah gets 4 and Stephen gets 3. In a case where Sarah splits and Stephen steals, then Sarah's going to get 2 and Stephen will get 4. In a case where Sarah steals and Stephen splits, Sarah gets 3 and Stephen gets 2. In a case where Sarah steals and Stephen steals, Sarah gets 1 and Stephen gets 2. Figure 2.3, another possible game based on the game frame of figure 2.1, In general, a player will act differently in different games, even if they are based on the same game frame, because her incentives and objectives as captured by her ranking of the outcomes will be different. For example, one can argue that in the game of Figure 2.2, a rational player 1 would choose steal, while in the game of Figure 2.3, the rational choice for player 1 is split. Test your understanding of the concepts introduced in this section by going through exercises in section 2.9.1 at the end of this chapter.